Hello, and welcome to Rick's Pipe Dream Magnetic Motor Generator Project Series, video number 21. You're probably wondering what you're looking at. Actually, this does look pretty strange, and well, maybe someone has an idea what this might be. Actually, what it is a aluminum bar, a hollow aluminum bar, 3/4 inches square and about 2.5 feet long. We're looking straight down the center of it, right through it, and looking out a window at my house, and you see the daylight in the background. And we're actually looking down a highway. And every once in a while you see a little bit of movement, and that's from cars that are passing by. It's reflections of those cars. It's a pretty strange sight. The aluminum, for some reason or other, it distorts the visual field when you look through the bar. If you're ever out in a hardware store and happen to see one of these square bars, pick it up and look through it. Be very careful that somebody doesn't bump into you and poke your eye out. But you can hold it up towards a light near the ceiling or whatever and look up through it, turn it, and you'll notice that there's a kaleidoscopic effect if you are turning it. It's really strange. And this also has some other strange properties. One of those is that if you happen to drop a magnet through this, if it's a neodymium magnet, time will slow down for the magnet, that is. While you're watching it, your time doesn't slow down. But this does act as a kind of a time tunnel, in that the neodymium magnet will be slowed down in its progress through the tube. Very strange. You may have seen this before. If not, this will probably be an interesting demonstration. Now, here's the same aluminum bar that we were just looking through, and I'm going to take a ceramic magnet. It's a very weak magnet, ceramic, and I'm going to drop it inside the tube, and you watch how quickly it falls down through and comes out the other end onto the towel which I've placed on the floor. Here it goes. Pretty quick. Now, here's one of the rotor magnets that I'm using, neodymium. I'm going to slip that in here and drop it, and watch this. There. Now you will notice that it took about 4 seconds for the rotor magnet to drop through the aluminum tube, and this was quite a bit longer than it took for the ceramic magnet to fall through. It's a very strange property, the reaction between the aluminum and the neodymium magnet. And of course it is a unwanted property in any kind of assembly where we have moving magnets moving past aluminum. And this is a prime reason why I have stayed away from aluminum as much as possible in the build of this magnetic motor. However, that being said, the 5 pieces of aluminum that you now see on my dining room floor will be included in the build. I will be keeping them at a substantial distance from the rotor magnets, however, and I believe that there won't be any undue interference that would cause the rotor to slow down. I'll explain what these pieces are in just a moment. Now you can see in this view that I've reconfigured the aluminum pieces that were shown in the previous view, and these are now laying on top of a length of wooden board, and they will be mounted to the board, and these pieces make up the stator carriage rail. Now the rail will be made adjustable for height as well as angle, and the stator carriage will slide back and forth on the rail. Now this view shows the actual stator tracking carriage and shows it suspended from the carriage rail. Now the two round white objects are actually rollers, and these will follow the curvature of the rotor track, and this is what will give the carriage the positioning and timing that's needed. You can see that everything is mounted on a piece of clear polycarbonate material, 1/4 inch thick, and the stator magnet can be seen mounted underneath the polycarbonate material. It's easy to see everything through the clear polycarbonate, and that's why I chose that material. Now here you see the underside of the stator carriage, and you can see the components all mounted on the carriage. At the ends of the carriage you can see the PTFE slider blocks, and these are set into grooves in the anodized aluminum slider rail, and they slide back and forth very freely, and it has an excellent sliding action, requiring only about 1 ounce of force to move the stator carriage. Now here's what all of this looks like when it's mounted on the pipe dream apparatus. You see the wooden board is attached directly to the PVC pipe of the frame, and the stator carriage slider bar is mounted to the wood board, and it's set at the same angle as the wheel, the slope of the wheel surface. And you can see that the stator carriage is suspended underneath the slider bar, and that it moves quite nicely here. Very nicely. As I said before, it only takes about 1 ounce of force to move the stator carriage. Actually, it's moving by itself right now because of the downhill slope to it. Now there is one more crucial piece involved in this magnetic motor, and that is the timing track, of course. And that's exactly what you see here. I have a strip of timing track material attached to a masonite test arc. I have several of these arcs cut out and ready for use. I see that we're nearly out of time, so I'm going to leave you with this parting view of the test track arc mounted on the rotor's polycarbonate ring. Thanks for watching.